Hi, my name is Vikram. I previously worked with LinkedIn with the ads engineering team. I have since been working on my own startup and on building Supergraph. Thank you. I'm super excited to share Supergraph with the Postgres community. Supergraph is a GraphQL to SQL compiler written in Go that just works out of the box. It is specifically designed for Postgres and works with most Postgres compatible databases as well. So let me tell you a story. From my experience building apps, mobile web, there are two main sections of work that go into, go into it. One is the front-end UI that has a certain set, skill set of engineers that works on it. Usually JavaScript, React, Vue, that with engineers with that skill sets, and on the back end, it's usually the Rails or Java or Go engineers, or one of the other backend languages, Python, that are mostly involved with querying databases. I've gone even as far as to say that 90% of backend API work involves databases. It's either reading, writing, the whole building CRUD APIs. This was not something I enjoyed. I would rather work on the meaty, interesting, core components of an application, and and never wanted to spend time building these same CRUD APIs for users, photos, whatever you're dealing with. CRUD APIs are, it's not just annoying to build. They're also, something you have to maintain. Yes, there are some generators out there, but most of them are pretty limited. They, they don't really, they aren't as flexible as the needs of the UI. So this problem kind of plagued me for a while. I mean, as long as I've been building apps, and I have tried to find a solution to this. And while looking, I stumbled on GraphQL. So let me kind of backtrack a bit and say, yes, while SQL is, obviously great, I have, grown to love it while building this compiler. I see the power of, just Postgres as a database, SQL as an interface to it. It's obviously, you can throw away so much code that I know people have written that just, is done more efficiently in Postgres itself. And this kind of got me thinking. I was like, if Postgres is so great, why isn't it taken more advantage of in the web development world, right? Why are developers still writing inefficient N+1 queries or trying to reinvent join themselves? Another common pattern is if you need, say, a user and all this posts, often instead of using a join, which is kind of scary, surprisingly. People tend to fetch the user first in one query, then issue a second query to fetch all his related posts, and then kind of write their own join using like a hash map or something inefficient. And N+1 queries are another side effect of this, where you need a bunch of information and you're making multiple queries to fetch it. And then kind of mashing it all together. So all of this is obviously results in inefficient query patterns, slow access, and and just an app that's and code that no one really wants to maintain. And obviously, yeah, a good answer, solution here would be, why don't these devs learn SQL? Well, SQL is not fancy, right? Developers would rather today learn machine learning, deep learning. This is stuff that helps them professionally in their careers and everything, or if they want to double down, there's already enough for them to learn in React, Vue, the changing browsers and browser APIs. There's so much going on there that context switching into SQL and then learning it, learning the exact dialect from MySQL, Postgres, it's not something most developers will find time to do. Also, a lot of them find ORMs are kind of good enough, and they just tend to use them. And additionally, these ORMs, are sometimes, the ORM needs you to actually tell it to join things. It's not going to do it on its own. And again, they just end up using the most basics parts of the ORM to just, query a single table and get the results back as an object. And, don't do anything more and still make those n+1 queries to find the related objects. So in short, SQL, learning SQL is not a solution. I don't see it realistically happening, in a wide scale. And there's lots of new stuff being added to SQL, CTEs, recursive CTEs, window functions, and it's, I see that gap just widening further. So so now I built I was working on my own startup, and I obviously wanted a solution to this. So being what all lazy programmers do, kind of find an escape from their day job and kind of sidetrack into another project that interests them, and that turned out to be Supergraph. So when I stumbled on GraphQL, GraphQL is this really nice schema. It's a standard way to fetch data from a backend, but it essentially required me to do all the code myself. So I still had to, even though the GraphQL query came in, and some kind of GraphQL framework parsed it, I would still need to do all the work of decoding, kind of making the API call, the SQL calls, and all of that logic. And then if for the next GraphQL API, I'd have to do that again. So there was still a lot of code I had to do. Instead, I decided to build a compiler. So which basically took the incoming GraphQL query, it parsed it, lexed it and parsed it and built the AST, and then it queried the database for all its information in its relationship graph and its tables and column types, and then it took all of this information along with the GraphQL AST, put it all together, and then wrote out really efficient SQL. And and essentially that meant that I would have to do no work other than issue GraphQL queries and just get back the data I need. So one of the, this is a common problem. This, for example, this is an app that I'm working on. It's called 42 Papers. UIs these days are complex. There's a lot of information you need, right? I mean, just to render the tabs on top, it's like, the name, whether you follow the person or not, or the titles of these papers and descriptions and, who shared them, and there's a whole lot of information. And your app needs to be fast. So you don't really want to make, 50 API calls for this information. You essentially want to make one, maybe two. And these requirements are always changing, right? Product managers might come down the line and say, hey, we don't need one name. We need the first name and the last name. We also need the picture here, and we need the description over here. So now the front-end developer traditionally would have to, open a ticket with the back-end developer and ask him to do the work to add these extra fields to the API. And this is slow. I mean, there's so much coordination that's needed just to, change a single page. So Supergraph essentially gives front-end developers all the power. They know what data they need because they're basically building the UI, and they write down the GraphQL query for that, those data needs. And Supergraph essentially just gives back JSON in the exact structure that they want it in, with all the data that they need. And from a backend perspective, it's very efficient because no matter how much data you're requesting, Supergraph essentially generates just one SQL query, even if for like deeply nested, objects, relationships. For example, say I'm building a blog, right? As a developer, I would, need to fetch all the posts, all the votes on each post, the authors of each post, or maybe author, and all the related comments, and the authors and who commented on things, and maybe the votes on the comments. You get my drift. And this traditionally would need someone to build an API backend, right? It would take a bunch of time. I mean, it could take several days to a week to kind of write down all the efficient, figure out the REST APIs or whatever, and then write all the code to efficiently fetch all of that, and then you have to maintain it and you write tests around it. So it's a fair bit of work. But with Supergraph, I mean, it's essentially less than 5 minutes. It's just this query. You write it down. The front-end developer can do it, and boom, he gets back the data he needs. So at this point, the question I often get is, yes, well, if this is the case, then in production, can't anyone just like issue any GraphQL query against your application and get data he should not be seeing? No, because the way Supergraph works is that in development mode, as the developer is working building his app, his queries are saved to an allow list. So essentially, it is only queries and the fields and stuff defined in those queries in the allow list that are then executed in production. And even in production, they are built into prepared statements. So they're, so basically it's pretty efficient and, safe. Yeah, this is kind of a joke. GraphQL is kind of really familiar territory for front-end developers. It's obviously has lots of documentation out there, great clients, and if you kind of squint just right, it looks like JSON or JavaScript. It's in that it's in that frame of reference, so it's kind of easy for them to just pick up and run with. Supergraph supports like complex nested GraphQL queries, like the one I mentioned, where you're fetching a user, all his blog posts, all the comments, likes related to that, maybe the comments, everything related to the comments. So there's a lot of related data that you're fetching in just one query, and and since Supergraph knows about all the internals of your database schema, you'll know the indexes, the tables, the relationships. It can write out the most efficient query to fetch that information for you. It's not only nested. Queries. It's also nested inserts, nested updates. For example, if you want to create a user and the blog post that he just wrote at the same time, Supergraph can build a query for you to do that, and it would just be one single query, updating or inserting into multiple tables. So even that would just be compiled into one query. This is, obviously, to everyone familiar with Postgres, it uses the magic of CTEs to do that. This is another example of some kind of a chat system maybe that you're building, where you have threaded posts, topics and authors, and you have a user, the current logged in user, and a whole bunch of information. And to build an API that can give you all of this, I would say that would take about a week of for most developers to kind of get right. And if you're in the REST world, there's a whole bunch of other decisions you have to make that I don't enjoy. Like what is the right REST URL that should return this information, right? So in Supergraph world, you basically, that's all you do. You write out the query, and the SQL is automatically generated in the backend. Obviously the developer doesn't even see it. It's long because you're asking for, and I had to trim it. The SQL is longer, mostly because it's it's pretty formatted, and it's just a lot, right? You're fetching a lot of information from a lot of related tables, and Supergraph essentially uses Postgres to even build the JSON structure. So it's a little large query, but that does not mean it's a slow query. It uses the right indexes, and it's lightning fast. So essentially, with Supergraph and Postgres, APIs that took weeks to build, or more, now take less than 5 minutes. And essentially, you have and you have no code to maintain at the end of this. And as Supergraph improves, as Postgres has new capabilities, your Supergraph will just take leverage those and generate even better SQL, which will potentially result in even better, faster queries, right? So you get all of that out of the box, and you basically don't have to do much. Another advantage of writing your own generating SQL is you can do all kinds of stuff based on what you're generating the SQL for. Another feature of GraphQL is subscriptions. So subscriptions is when you subscribe to a query, your client subscribes to a query, and all he wants is updates on that query. So if there's a new customer, there's a new blog post, you just want that query only when that thing changes. So in Supergraph, subscriptions is implemented using a bunch of really efficient things, like Go concurrency model using channels. So it's it's lock-free code for the most part, and in Postgres it generates an interesting join query where it joins the generated SQL to another kind of temporary table with all the subscribers and their variable and all the variables that they have passed. So essentially for 10,000 subscribers, everyone bringing their own version the variables, maybe each 10,000 guy, all the 10,000 subscribers are looking for 10,000 updates on 10,000 different blog posts, maybe, right? At the end, in within your database, that will just result in one query. So that's amazing, right? So for like 100K subscribers who are waiting for updates, you will essentially have 5-10 queries running on your database every few seconds. That's literally nothing. If you and only when the data changes, it uses the magic of WebSockets to deliver that to the client. So no more having to build these polling kind of APIs, which are highly inefficient, because if you didn't have subscriptions and a client polled for these updates, there would be for 100,000 clients, there would be 100,000 queries being executed on your database. And now there are 5 or 10. That's a huge order of magnitudes more efficient, right? So it's really interesting how we were able to build this kind of subscription system with leverage, because of the fact that we were writing the SQL and we had full control over it. And obviously you also get cursor pagination and all of this for free. So if it'll auto paginate your cursor, so if you need just the latest blog posts or latest customers, it'll make sure you just get those. And the whole related SQL, all the related data along with that, right? The whole nested GraphQL query. There's also other really cool things that we've managed to do. We unfortunately could not leverage the access control, role-based access control of that Postgres has. It was very limiting, and it did not fit in, did not give us the flexibility we needed for it to work with subscriptions and all of this other stuff. So we had to invent our own, which is kind of similar, but I'd say it's more powerful and does a lot more, including the ability to have attribute-based access control, where you could have based on on a query, you can assign a user a role. And based on the role, the SQL query will be generated in a slightly different way. Full text search, this is again, obviously a Postgres internal feature, but we're able to expose it really easy to the users, where you can now use full text search. You just search : and and then get all the related data related to the the table that that you are searching on and stuff. Efficient cursor pagination. Here we have a really complex system to figure out what are the right predicate where clause that we have to build based on the the order by sequence, and we generate basically this kind of an opaque cursor that you pass back. It's kind of encrypted. You pass back, and it's you efficiently fetch the next batch of results that you're looking for. This is great for building things like infinite scroll and stuff. It's very efficient. Polymorphic relationships. A lot of people don't like this, but this is called polymorphic associations. It was introduced by Rails, I think, a while ago, where instead of having foreign keys, you have you can have a relationship built with two columns. One is being a type column and one is an ID column. Obviously it does not leverage Postgres things, but essentially it's out there. A lot of people use it, and we we support union GraphQL queries where you can say, okay, based on whatever type that is, return one of these objects back. It supports that out of the box. There are lots of other interesting things that Supergraph does. For example, if you're joining using an array column, if you have an array of IDs of say, and then you have a separate column for tags, table for tags, and you need to join the two. It will know this is an array column, and it cannot just be joined with an equals. It needs a different kind of a operator, and it will essentially build that relationship, write out the SQL to make that relationship happen for you. So yeah, that's and a lot of little things. For example, you can if you have a JSON B field column, which has then you can now treat it as if it was another table. So you can essentially, if say you had a user and within the user there was a JSON B column with, I don't know, a list of email addresses or something, right? And you could essentially now write your GraphQL query saying user and then email, and then the fields within that, within the JSON rows within the JSON B list and you could query it like it's a separate table with limit and where and all of that. Yeah, so it has a lot of these little really useful things that it just does out of the box, because it's essentially generating the SQL to do that, right? Supergraph is a Go application, so it is just a single binary. That's how Go is. It's really lightweight, very low memory usage, and it's obviously very, very fast. So you can run it as a standalone service where it's essentially the core library along with all these bells and whistles to handle authentication, tracing, WebSockets, and so much. I mean, it has built-in migrations framework to manage your Postgres database migrations. It has a JavaScript, so it's kind of interesting. We have a JavaScript-based seeding tool where you can write seed scripts to kind of seed your database in development mode. You want some data in your database when you're essentially building your app on your laptop or whatever, and this allows you to do that, and has a lot of these little really useful tools. You can do Supergraph new app, and it'll build out the scaffolds for your everything you need, your config files, and it will have YAML files for cloud run and all these deploying to different clouds and all of that in there. And you, as well as the Go library, right? So if you don't really want to go with the standalone app, you can leverage Supergraph as a library, just the core. So you can pull it, I know several people who use Supergraph almost as an ORM. I hesitate to call it an ORM, but essentially it is the way they talk to their database within their app. So this is not GraphQL coming from the client, but this is GraphQL hard-coded within their Go code that they pass to, use it to query their own database within their Go application. So, and the APIs expose the subscription. So, that's something really cool that you can just get as a library. You don't have to do anything. It started, Supergraph started, I'd say about a little over a year ago. So it's been my kind of pet project. It's not a full-time thing. So, but it's been slowly and steadily growing. We've kind of hit over 1K stars, 25 plus contributors, and that's kind of all we have. We have a lot of people working out there who are on large pull requests at the moment. We have a Discord community that is also kind of growing. It's pretty big already. A lot of discussions around new features and things we need to build. It's very interesting. I'm really excited to see this kind of stuff that is in the pipeline. I think it's going to make app development so much more of a pleasure for me going ahead, because so much a Supergraph will just do for me. And I can then focus mostly on the the meatier parts of my app, the UI, the stuff that really really matters. And I have this out of the box, super fast, amazing API in Go, running on Postgres, which is like a dream. It's used in production at several places, including my own startup, 42papers.com. It's a pretty high traffic site, and it works. And interestingly enough, I run it on a serverless platform. So, because it's Go, even, if it's kind of scaled down to 0, it kind of starts up really, really fast. You can go from cold start to serving a request and, response back out within milliseconds, right? Hundreds of milliseconds. And it has a lot of documentation. So, we've put in a lot of effort to have really good documentation and, an active community on Discord. So they kind of helps people adopt it. Thank you so much for your time. Feel free to reach out to me over Twitter. We're definitely excited. Love to have you, try it out and kind of, join the community. Thanks.